Good to go. Hi, everyone. Today, I would like to tell you a story where several years ago, maybe over a decade, when I was working in the same company as I'm working right now, we were looking at our application, quite nicely tested, well maintained, but it was huge, and it started to cause problems. And the team of four people and me, we started exploring ways how we can improve the way how to maintain the application, how to speed up our work, how to make us more productive. So we started talking with other people who already have some experience with tackling such problem. We were looking at our colleagues, we were going on the conferences, we were speaking, we were talking with speakers where they are whenever they were sharing their ideas how to tackle monolithical system, whenever they were talking how to tackle legacy system. And one day I was talking with my old friend who told me about cool way of tackling such huge system. He started to tell me more about microservices. It wasn't new for me, but the difference was he already had 2 years experience on production with that system. And he was really energized whenever he was talking about the solution they've come up with, all the problems they were able to solve just by introducing this architecture. And when someone is full of energy, when they are talking to you, you are getting excited as well. So I was buzzed with that, with his monologue. And then his colleague, his friend joined us, and she told that was the person who were involved into introducing the microservices architecture in their project. And that was also the person who was maintaining the development of microservices in their firm. And she asked me, Sebastian, yeah, this is all true, that whatever you just heard, but do you know what was the biggest problem with microservices? The biggest one, when we started to think about it and explore it. The microservices was only the first decision we had to make. It wasn't the solution that solved all our problems. All our problems went away. The microservices solved the first initial problem. We knew our application will be big. We knew there are a lot of stakeholders from various areas that will bring requirements to us. We knew there will be multiple teams that will have to continuously, for several years or even more, maintain the application. So that was only the first problem we solved. We introduced the boundaries thanks to the microservices. But there was a lot more new problems we faced during that journey. And today I will tell you something about the journey, the lesson they learned. I won't use their business area, so example will be about online shop. Just a thought. There will be not much about the domain itself, but this is good to have for the example purpose. So let me tell you about their journey. So they got their first decision. Let's go with microservices. That was well justified. They knew that's a better way to write this application rather than using monolith. First problem they faced, or firstly, on the very beginning, it was all about fun. Okay, so we are going with microservices. What we are going to use? Cloud, VMs, containers, maybe cloud agnostic, maybe Kubernetes. Let's use something for the code architecture, hexagonal architecture, clean architecture, onion architecture, domain-driven, strategic, and so on and so on. Plenty of solutions come up with on top of their head. Plenty of solutions that on that days were connected with the microservices really strongly. I know sagas, event-driven architecture. They want to include that all into their system. Why is that? Due to really good reasons. First, All of that were validated solutions. They knew it works in action. They knew there is a lot of teams who were sharing their experience on the articles, on the blog, during the conferences, where they successfully used something like that. So that was, from their perspective, that was a really good choice. Forget about old solutions. If we are going with microservices, let's do that good from the very beginning. All good reasons. But does it really make sense? Does it really make sense to use all that and even more? Because right now we've got machine learning, AI. Like it's more spread in the industry. More people have got some experience with that. So there is more and more things that you can use. And does it really make sense? There are a couple of questions you have to ask yourself before going in that direction. And unfortunately, not all of them are purely technical. So first thing, with what people you will going to introduce that microservices? Let's imagine you've got, I don't know, 5 teams, 7 devs in each team. And they've got, I don't know, each and every person is great software developer with 10 years of experience. Okay, quite good teams. Great knowledge in their head. Yet, what if they've got only experience with monolithical services? This is all new to them. They need to learn that. And this is not the biggest challenge to learn something new. The problem is that they have to unlearn what is already in their head. They've got the patterns. They've got their simplification, shortcuts in their brain, which is good, which is really great. This is how we are getting more and more experienced, and within time we are getting faster with solving the problem. But if you are jumping into something totally new, the first step is not to dive into that, but unlearn your habits. So that was the challenge that they found. Unfortunately, on that day, they had zero experience with the microservices. So they went to another question. What is really required? What do we really need to have right now? Okay, do we really need to have DDD? Do we really see the value in even sourcing right now in our requirements? Maybe no. Okay, do we know whether NoSQL should be used somewhere? Okay, that's we don't know. So based on that question, they decided to firstly remove anything from that list that is not crucial for them to move forward, and leave the doors open for those solutions that may be required for them when they will learn something new. But technology choice is a tricky one, because whenever we are trying to build something new, we want to do it well. We are looking for support in industry. We are picking the validated solutions. But remember, everything that is new requires learning. So limit that amount of new things, because thanks to that you are managing the risk better. Thanks to that there is a greater chance you will succeed. Another thing, so they knew what to do with the technology stack. Another thing is component. Okay, we are going with microservices, so definitely we need to divide our online shop into something, into microservices. Makes sense. So their first try was to identify the business area, the stakeholders they had, and based on those identification, they created their initial draft of the services. So there is some warehouse where we'll put our products. We need to take care of the supply, assortment, sale, and so on and so on and so on. And they build all of that. And why they identified the business areas? Because they heard that the business language is great to put into some boundaries, because thanks to that, it's easier to understand what the business is telling you. It's easier to later include some new requirements or new changes into existing boundaries. Okay, great. So, does it make sense? This is a good starting point. Yet, when they were learning more and more about their application, about the requirements they need to introduce and fulfill, they discover a couple of things. Firstly, they've got only 5 teams. So when you are dividing your components and then you are putting the ownership of the component to the team, it's worth to take into consideration how business knowledge within the component works with another component that is for the same team. So that was the first factor they had to take into consideration to make sure their development in future will be still as productive as on the first day. Teams, shape of the team. The amount of the teams, that's the first thing, how they are collocated. If this is all the people in the same room and we are just divided by desks, no problem, we can talk with each other. But if this is like, those are teams in various places in the world, definitely we need to put an ownership in a different manner. Why is that? Because if warehouses and, just an example, and the supply need to talk with each other, the components itself, the service by design must talk with each other all the time, and warehouse is developed in Asia, supplies are developed in the US, there is a really tiny margin of time when they can talk with each other. And based on the requirements, there is a lot of conversation between those services. So this is another factor they had to take into consideration. Maybe it will be worth to merge the initial design based on the conversation between the components. Maybe there will be something more. Maybe we are heavily querying that system assortment, like there are millions of queries within a minute, but we are rarely adding something new. Maybe it was to divide it even further. So that was good initial starting point, but definitely what they learn is the fact they need to accept it will going to change. Not even, and it wasn't like about long future. It was during the conversation, during the initial conversation, this design was changing. So another problem, how they will need to introduce all the architecture, all the patterns to be prepared for such continuous changing. Another problem, so they've got technologies, they've got their component boundaries, they know what new problems will come in future. So that now they sit and discuss about the architecture of the code. Yeah, finally, we saw the problems. We know that we need to take into consideration the teams, their knowledge, how fast they will learn new things. Cool. This is all like social part of the architecture. Right now, let's talk about the code. What will be the architecture of the code? Let's go with something really great. Let's use port and adapters architecture, because in the literature, in the articles, you can read that the boundaries within that architecture are really strong. Thanks to that architecture, you can really isolate your domain. Thanks to that isolation, you can really well test it. You can introduce rich domain model inside. You can use, if you will like to, you can use JDD tactical patterns in there, and you already have good direction where to go. You can separate the frameworks, libraries from your domain. It will be easier to maintain. Sounds clever. But once again, does it really make sense? It depends. That's a great answer. It depends. But on what we need to take into consideration to make that decision. Remember that, firstly, it requires knowledge. You need to understand what the port and adapter architecture is. That's the first thing. Not everyone knows it. Second, you need to understand why it's beneficial to maintain within a time all the interfaces, all the ports on the adapters, this separation, this isolation of the domain, because this is the cost of the architecture. If used in a good place, it will pay off. But if it is used in a wrong place, then it will be just cost without benefits. So they had to take into consideration a few additional things. How important the service is for our online shop. Definitely the sale is more important than the invoicing. Why is that? Because in sale, this is where we would like to introduce the business advantage. This is where business will think how to improve that process, how to make it more performant, how to make it more better for our user. On the other hand, invoicing, okay, maybe we'll use another service, maybe we'll use library. This is not something that we will explore and learn how to create the invoice. We'll use something that already exists. And in such places like invoicing, that architecture is not a good choice. It will be too much. It will be too big overhead. So they learn that architecture should depend on the importance of your service. And the problem is they couldn't make that decision upfront, or let's use port and adapter by default. No, whenever they were looking into the new service, they had to have exactly the same conversation all over again. And based on the factors, they were making the decision. Okay, and we still didn't explore functionality at all. So let's take a look how it started to look like when they look into more details. So first, they list all their users, some of them, with some usage of the components. So in example, workers from the warehouse have to use the warehouse to get the information about what is what is on the shelves, information from the supply to know where the assortment will reach the point, and seems that's all. And they listed that, created that for all of them. Of course, maybe not all the connectivities are there, but gave them some information about the complexity of the system they will have to introduce. Something they knew on the very beginning was that they are planning to introduce several applications for each and every user, just to make it simpler for them to use, not switch the accounts, not use some big UI and jump from pages to pages. No, if you are from logistic department, you've got your own UI, and so on and so on and so on. And each and every UI can be a mobile app, can be a mobile apps for various phones. In example, shop customers, of course, I can force my customer to use whatever you like supplier, logistic department, they will use what I will provide. But from our customers, we need to be open for everything. So that was something they treated as a certain thing. And it was developed, delegated to other teams. Someone else will work on that. So they were left only with the backend system. Still, UI applications were developed in their firm. So first question, how those applications can talk with us? Idea number one, let's make it simple. Based on the lesson they learned so far, to not get to overcomplicated solution, to not over-engineer, let's make it simple. Let's connect with the components you want to connect. Let's get the information on trigger the action directly by talking with the component. Okay? But what if infrastructure will going to change? Because, as you remember, they already learned infrastructure will going to change. There will be new components in our architecture. We will merge some components into one. We will divide existing components, and so on and so on. And it would require, if we will leave it as it is, it will require for each and every UI to be aware of what is going to change. And what is even more problematic, by introducing something new, we will have to analyze all that places and make sure that that will be supported. And what if, in case of the customer shop UI, when we've got various instances, iPhone, Apple, browser, and whatever else? Okay, a lot of analysis. So how to tackle that? And they were thinking. So they come up with an idea. Let's put some component in between, API gateway. Yeah, so thanks to that, all the requests from UI goes to here. No problem. Thanks to that, our backend architecture is isolated. We can merge that into the one huge monolith, and it has zero impact on our UI. We can divide that further. It has zero impact on our UI. We can scale up, down, whatever. Those services are not aware. Great, that was really nice solution. And yet, when they ask questions, so who would like to support that? Who would like to deliver that, maintain that within the time? That was a new problem. Because it's something that talks with everything. And everything is using that API gateway. So that was a tricky question. And additionally, we've got a single point of failure. We just introduced that. Right now, if API gateway goes down, then we are doomed. Our application is not available anymore. So they come up with an idea. Okay, API gateway is still good solution because thanks to that we are isolated. So let's introduce API gateway for each and every component, for each and every UI. So from the ownership perspective, it was easier because thanks to that they had several teams. So each team got one component. They had to maintain that. Okay, that was kind of fair. On the other hand, you didn't have to worry about all the communications because there is only one part of that. Additionally, you were worrying only about one client. If something were changing and you knew that this change must be maintained in your API gateway, you didn't care how many UIs you've got here, how many variations of UIs you've got in here, because that was isolated problem. Okay, great. So they had their solution. Isolated, they can change, they can modify, they can grow, they can get smaller. Not a problem. Right now, we sort it out. Yet, didn't we return to the initial problem? On the very beginning, we had that with all that connectivities. Right now, we've got this, that, and all that connectivities. So, no. To be honest, no, this is not the initial problem. Remember that we isolated our backend architecture. Right now, UIs can be developed on their own, and they don't know how we are built. So this is the problem we definitely solved. But what about API changes in between? So this still exists. What if I will divide my warehouse into two, then my API needs to know about that. What if my service will go down and I will bring it up, but it will be on different, in different container. There will be different address to it. Okay, so another problem. Once again about the failure. So they introduced service registry. Also, nothing fancy. That was already available on the market. This is known solution, validated, and for most of that components you already have so either a library or services available in the cloud providers. So great. So they solved that problem. Right now, the change of the API is irrelevant because each and every service registers themselves, and API gets an address of the service from the service registry. If it's not available, it can retrieve it once again. If there is a failure of the service, and we are bringing that up, we are re-registering that service, and so on and so on. So API scaling up, scaling down was somehow tackled. And we could explore that problem further, because here we had an API. What about authentication? Just see how they were focused on business segregation. And right now, they need to tackle things like logging, authentication, authorization, and many, many others in various places. And it must be consistent. The more services, the more teams are working on it, the consistency will be, firstly, more important to observe how your system evolves. On the other hand, not so easy to achieve because you've got more people, more great ideas that they want to try. Let's jump to another aspect of that. So how to perform action. So we know what problems comes with the communication from UI to our system. How we can perform an action, how we can really change something in our system. So let's say about purchasing the product, because this is like essence of our application. So They list all the components, they list all the steps. So in sale, we are ordering, then we have to log the product in assortment. We need to receive the information from from the shipment about the transport offer. Once we got those two done, then we can pay. And once we are paying, we are sending the invoice from accounting to our customer. We are preparing the package to be sent to our customer, and we are informing we are confirming the transport with the shipment, so that we know they will get the package once it's ready. Okay, so once again, no over engineering. Let's make it simple, like that. And the same question: what to do in case of failure? What to do if component goes down? If any of that component with that way of communication, like synchronous communication, goes down, then the operation is impossible to be fulfilled. Okay, so how to make it safer? How to make sure in more scenarios this operation can succeed? They started with two questions. Question number one: what is independent? Like, what we can do without affecting initial process. And they were talking with each other, and they decided that those three blocks, parts of the process, are totally, like, shouldn't have an impact firstly on that, and shouldn't have an impact on each other. So what does it mean? If my payment succeeds, so I just bought a phone, I don't want to have let's say, rollback if invoice wasn't able to be generated. No, why? I don't care. It can be generated in an hour, in the next day, in a week. Irrelevant. Additionally, if my invoicing will fail, I don't have. There is no reason that this failure will have an impact on the shipment itself. So I'm confirming the transport, good. And if there is a problem with the invoice, okay, so there is a problem with the invoice. We can solve that in isolation. So the longer process, the more things like that you can find. In a day process, they found those three boxes. So how they could change it? By the asynchronous communication. They introduced events there. So whenever sale is successful, they were publishing the event products were bought. Great. And then if those services are not up and running, not a problem, event was published. If this component will be already up, it can consume it and process successfully. If there will be any failure, we can tackle that in isolation. Great, like quite clever, because right now any failure in those three components doesn't have any impact on the payment, on the purchase itself. Yet, it doesn't solve all the problems. So problem number one, we've got another component, like message broker, whatever you want to have it there. I know that they are highly available components, but this is yet another piece that unfortunately can fail as well. That's the first thing. Another thing, we are bringing new concept to our architecture, events. When should I publish events? If I'm starting publishing events, should I publish them everywhere? What kind of information should be in the event? How the event should be designed? How I can trace the events through my architecture, through the process? How long I should keep them? Because all those components can be not up and running, like down. So how long I should keep them in here? Should I store them somewhere separately? Should I start thinking about event sourcing, or something different? Or this is like just an event? Couple of new problems, of new questions they need to answer. Question number two regarding the processing, what requires confirmation? So from their perspective, that was all the pieces that requires confirmation. You cannot proceed the order to payment before the assortment is locked and before the shipment didn't return the information about the transport offered. Okay, so in that case, simplicity win, no over engineering. They are happy. They could use the way of solving the the problems from past, so simply asynchronous communication, great, because it must, we need to have an answer. Without the answer, we can do nothing. And once again, to be honest, it brings more and more problem. If you will start relying on synchronous communication, and your goal are microservices, then your application overall became more and more fragile. Because right now, if any of those components go down, then there is no sale. So we mitigated the risk because we eliminated 3 components. They are no longer part of this big process, but there are still additional 2. Of course, except the one that holds all the logic. So there is lower risk. The reliability of the application of this process growth, but overall we can still fail. So this problem still exists. Can they use asynchronous communication in here? Like request response can be done? Okay, if yes, how long customer should wait for that? More and more questions, and each and every asynchronous communication brings another complexity into your infrastructure. Okay, so they know that, unfortunately, something can fail. Whatever they did, something still can fail. So when they are looking at such process, they ask additional question, something they also discover. Firstly, what can we retry? Maybe there are some operations that we can simply retry. Invoicing, okay? I'm generating the invoice, no success. Let's try again, and again, and again, in 10 minutes, in an hour, in a day, in a week. Let's try until you succeed. Payment, okay, I'm trying to pay. I lost connectivity with, I don't know, my bank. Okay, let's try again. Maybe this time we'll succeed. Package preparation, transport confirmation, transport offer. I want to get an offer from this transport. Maybe I can retry if there is nothing available right now. Okay, but the problem is, firstly, do we really know the failure happened? Payment. I'm trying to pay, and there is no response. Does it mean there is no payment? Or it means that I didn't receive the confirmation that payment happened? I'm sending the request, payment component did the work, and sent to me the information back, but on that communication something went wrong. We need to validate that before we will simply use blindly use retry. Additional question, can I retry infinitely, like invoicing? Yes, in here, of course. So it must succeed. This operation cannot fail. Like if I made a mistake during the deployment and the version of the library is wrong and I cannot generate any invoice, not a problem. Fix it, redeploy, and start generating invoices again. No problem with that. But some things cannot be retried infinitely, like payment. If the assortment is locked, should I let you to retry for a day, for a week, for a month? Most probably no, because I want to sell that product. So those are a couple of questions that you need to ask yourself and think how to make sure your process will compensate any kind of the failure, how your process will find out about the failure or success. And that was the second question, like, what do we have to compensate? So we need to compensate the payment, package preparation, and in here right now, that's all. So if payment won't succeed, how it can fail? Like simply, I got no money in my bank account, failed, and there were some locking already on the assortment. So I need to compensate that. Package preparation, it's not even, and this is quite nice because this is even outside of our application. Let's say there is a phone in our warehouse, and the warehouse worker took that phone, want to put that in the package, and it dropped. Phone is broken. Happened. In my system, I've got all the information. There is a phone there, but I just lost it. Okay, I need to be prepared for the compensation. So they answered that question. So they have a payment. If the payment failed, they need to unlock it. If the package couldn't be prepared, this is naive idea, but they will return money, cancel transport, reverse the invoice, and if they will return the money, they will unlock in some condition assortment. Like, does it solve all the problems? To be honest, it brings more complexity. Such compensation would be simply handled by rollback of the transaction in case of monolithic application. So this is new complexity they just bring. Additionally, within each and every communication like that, they need to ask themselves a question. Can be that asynchronous or synchronous. They need to go to the business and ask if this is the right way to compensate. This is not commit and rollback situation. This is about the business process that we need to compensate from the business perspective. This is another discussion with our stakeholders. So there are another problems. And the last problem I want to share with you they faced is about querying. So we know about the communication, something. We learn something about triggering the action. Let's see how they can get what they want to see. Let's imagine the customer of the shop wants to retrieve all their orders, and there are several things there. Within each so firstly, you need to retrieve the orders from sale, invoices, all the invoices attached to the order from accounting, all the details about the products from assortment, and the delivery information about the delivery from shipment. A lot of information that they want to see that on one screen. So, like, once again, naive approach is the connectivity. Of course, most probably you know what will be the challenge in here. What if something will going to fail? This component can fail, this component can fail, and so on. And there is no like dependency between each other. They can randomly be not available. And to be honest, such lack of response from their side doesn't have to be caused by issue with the network, issue with the container itself. It can be caused by redeployment, new release, rescaling, changing the IP, or something like that. So it can be simply the business as usual. So in case of such query, they come up with several ideas. Let's bring another validated solution into action because it will help us survive. If the request is not available, let's retry. Of course, we cannot retry infinitely, so let's break that, like return some information. In some situation, maybe we can use cache to get the information. Maybe here, it doesn't change it so fast, so I could introduce the cache. Maybe in some way I can have multiple instances of that, and I can introduce load balancers and multiple instances of that component to mitigate the risk, to decrease the to decrease the problem with the failures, and thanks to that make this query more reliable. And you've got those blocks only on that communication. Of course, it can be here. Of course, what is even tricky, they can be in various combinations, depends on the query itself. Not always you can use the same patterns, not always you will use them in the same way. Okay, another question. What if something will fail? And another, once again, so all those things, we've got already validated solution. There are libraries, services that you can simply use. You don't have to write them from scratch. Good for you, good for me. But this is additional complexity. Everywhere in here, something can go wrong. Okay, so how to resolve that? They start to explore new ways of solving that problem in microservices world, and they find out something which is called command query responsibility segregation, and they reversed a little bit the way how query is prepared. Instead of communication from the API to each and every service, they eliminated this synchronous call, and each and every service is publishing the event whenever something relevant for this query model happens. the event is published, and our query model is consuming those events and is building the view for the customers. Okay. Does it eliminate the problem? No. There is still a possibility of the failure. But previously we had 4 of them. Right now we've got 1. So it's easier to mitigate. The risk is lower. Additionally, I can have some performance benefits out of it, because in here I can have a view prepared for being queried. There can be like really smart indexes over there to support our customer API. But no, problems are not eliminated. Still, we've got the problem with the connectivity. And additionally, once again, how long I should keep the events here? How outdated the data can be here, because they will be. Like, even if everything is up and running, something happens here, and it must go through this path until it will be visible in here. So can I have those information outdated? If I'm making decision, if my customer is making decision based on that data and they are outdated, should I compensate it somehow or not? Definitely I should talk with my business. So this is not only technical issues. There are also a lot of new conversation with the business. And there are more problems, like who will maintain service registry? Who will maintain the way how we are authenticating our services? How we will introduce observability? How we will keep that consistent? How we will design our events and make sure that all new events will be designed in similar way? How we will tackle with the backward or forward compatibility? And so on, and so on, and so on. There is so many problems. And the presentation itself is not to show you that, not to convince you that, no, this is no way to go. No, this is not it. I just wanted to highlight that microservices is just a decision that brings a couple of new costs, but also brings you a benefits. But the costs, each and every cost, require new solution. Each and every cost is a challenge, problem that you can either accept or try to solve. And once again, if you are talking about the architecture, each and every solution, a new solution of that cost brings you another cost that you also can accept or think how to resolve. But to be honest, it's not only about microservices. If you will get rid of the word microservices, and the statement would be simple, like each and every architecture decision is all about the cost and benefits, it will be still valid. So to be honest, you will have similar amount of problems with a monolith, but in many cases it's easier for us to tackle with monoliths because we are more familiar with them. This is the first aspect I told you. We know how to tackle with those issues. We've got an experience. In here, you need to firstly unlearn your old ways, learn something new, and the third, know where to use it. Thank you very much. I'm Sebastian Malaca. I'm a developer, architect, leader at UBS. If you've got any question or you want to discuss about microservices or how to migrate from monolithical application to microservices, I will do my best to answer each and every question. Thank you very much.